This bulletin is the conclusion of a work started some years ago when FIB started to take sustainability very, very seriously and wanted that groups in every commission would deal with sustainability in detail in each aspect of the commissions of the FIB. And the result of that work is this bulletin that was published already a couple of years ago. And it's also a joint bulletin with PCI, the Precast Concrete Institute of the US, and we collaborated a lot. And the intention of the document was, as a state of the art, is to cover and to see what has been done in the world about sustainability in precast structures in detail. And what we have done is we did a review of the different regulations in the US, in Europe, of course, ISO in Brazil and in other countries that had some regulations and some, let's say, partial regulations about sustainability and how that was applied to precast structures. Then we made a review of the, let's say, particular research or particular publications about sustainability that were done already about precast structures. We had some publications in the FIB about environmental aspects and things like that. And then at the end of the bulletin, we tried to find a system to evaluate sustainability in precast structures. And I will go through all these aspects. And at the end, we have some examples. And I will try to go through one of these examples if we have the time to do that. So I will start with some ideas about sustainability. Now, for many, it looks obvious, but sustainability, it's very important that when we talk about sustainability, we take into account the three pillars. The three pillars of sustainability are environment, society, and economy. Normally, when we talk about sustainable solutions or sustainable elements, then we talk about only or mainly about environment. And it's important to balance. To balance doesn't mean that everything has the same weight or the same value, but at least we have to take into account all these three aspects in sustainability. This was already said in the Model Code 2010, and now in the development of the FIB Model Code 2020, this is more evident, and we will have some provisions for that, general provisions for that, and to take into account these three pillars. If we go a little more into one of the regulations, that is the Euro Codes of CIEN, we see that we have several developments of regulations in the three pillars, environmental, social, and economic, and regulations that go from general to particular. And this is quite important. And what we can see that we see the three colors of the three pillars here, and this is maybe interesting to understand that. And we have to find that these regulations are consistent and that they are related to each other. Up to now, we have a lot more development on the regulations in environmental performance, and let's say the whole world is really looking at the environmental performance. But we have to understand that it's not the only performance that we have to take a look. And if we go down to the product level, we found this, maybe you can read the Environmental Product Declarations, or EPDs. These EPDs are they are an evaluation of environmental aspects, of environmental burdens or loads, we can call it many ways, of products. And if we are talking about precast products, we also have in the document some examples of EPDs of precast products, like this example that I bring here. And this is very helpful, and this is very interesting, and this is, for now, this is being something that is being regulated, and the producers will have to prepare these EPDs. But only with the EPDs we have not the full information, because the EPDs give you mostly environmental aspects, and mosely from the beginning of the life of the product to the gate, so from the cradle to the gate. That means that it's the loads or environmental aspects until they leave the factory. But as you know, we have many other aspects that we have to consider in sustainability. One of the aspects that we are talking is that we have to consider the 3 pillars. In this sense, we are considering one of them, and only partially. Okay, so what we did in the document also was to take a look at what were the tools that have been used for buildings, for example, to evaluate sustainability. And we found several tools, some of them very successful, like LEED or BREEAM. And these tools, we found that they had a background behind them that was not really evident. There was no background documents or ways to see how this was evaluated. And these evaluations were done by points, and these points were given well by the organizers of these tools, but there was no link between the regulations and the tools. So what we did, we saw that what is sure is that there is a need in the world to evaluate sustainability, and there is a need to certify and to show the society that the buildings are really sustainable or efficient in the energy point of view and many other point of view. So this is a must that we must tackle. The engineers, civil engineers, or architects, or people around the construction industry, we need to tackle this issue, because otherwise, if we don't do that, other people will do that. And we need to take a look at how these things can be done, and give a proper background to how to do these things. So we evaluated these tools, some of them, for example, you see here LEED, BREEAM, and one of the other Verde. And we put in the different pillars of sustainability the weight, or how many points or how many indicators these tools have in their own aspects. And we saw that the environment was quite big in this idea, about 50%. About 20% economic aspects, and quite variable social aspect. And then they had other aspects that we could not put in any of these parameters. So now, at least we have an overview of what these tools are doing, these tools that follow their own rules. And so we wanted to try to give a step forward and try to make an open tool, an open idea of how to evaluate sustainability in buildings or in construction, in particular in precast elements. So the first thing we need to know is that we had to take into account this life cycle assessment, and we had to take the full life of the structure, not only like the EPDs from the cradle to the gate, but all the way to the structure. And we based our information in this bulletin 71 that deals about this integrated life cycle assessment. And this is a very interesting document that allows you to take into account how to deal with these aspects. And all the different phases that you have to take into account. Before we're talking about dealing with these different pillars. Now we deal about the whole life of the structure. And this is what we need to do. We need to do what we call today the circular economy, or circular way of designing. When the material comes and where it goes, and it's going to be reused. Today, it's one of the aspects that goes around precast elements is the everything that is about circularity and reuse. It's not more demolition and recycling, not only, but also design to be reused. And this is a very important aspect that in some countries is really something that we need to take into account. So we then took a look about what has precast structure can give to sustainability, and we knew some aspects. We did a SWOT analysis of strong and weaknesses and things like that. And of course, there were a feeling in the precast designers and industry that some things around the precast buildings are important, like these control conditions, the applications of new technologies in the first place in prefabrication, the possibility to have flexible structures, high span, long span structures, high strength concretes, and this was in a qualitative way something that we found that was very interesting, but we needed to evaluate them. And how to evaluate that? We know that we can recycle because we are in a factory, we have the material to ourselves, we can integrate all the thermal mass into the building. We know a lot of things, but we didn't know how to deal with that. And I'm going to show you some examples of what researchers and some studies were doing, and we know partially that some things could be done well in sustainability of precast structures. Today, we hear that industrialization is the key of many sustainable solutions, but we didn't know exactly how to deal with that, and I will show you how we can deal with that later. So, this format has been moved a little bit with the system, but this slide deals with comparison of hollow core slabs, which is a precast floor, and a cast in situ slab, and comparison the different energy consumption of both. I will go, so this is one of the studies that say, okay, if we use precast structures, if we take all the energy for all of them, then we see that we are using less energy. Okay, this is one aspect for one example. So this is maybe one idea. And then we have another example of another study in which we were dealing of energy here, we're dealing with cost here in France this time, and depending on the span and the different kind of floors for buildings, where are the costs and where different costs can be good, and this is one of the aspects that we can deal in sustainability. So you hear from corrugated steel plate floors to in situ bubble deck timber, or hollow core slabs or double T slabs, which are precast floors that are very efficient for long spans. Okay, so this is another example. Another example here is another study in the Netherlands about three different type of floor: hollow cores, shattering slab, or cast in situ, and I just highlighted two of the components. One is the concrete, the kilos of concrete per square meter used in the floor, and we see that both the shattering slab, partially precast, or the cast in situ use a lot more kilos of concrete. Maybe per cubic meter the precast element uses more, but for in the total building uses less. And I showed here another one, like the total waste, that also is smaller. If we take a look at the total mass of the building, total mass means the total elements that we put there, total cubic meters, if we want, of the building. Also, if you use precast, you use less cubic meter, less tons of materials. And this is one of the aspects that are important to take into account. And then another one, which is quite interesting, is evaluation of the transport of different kind of floors. And even if with precast floors we have bigger transports, we have a lot, like 1/3 less transports than we do in a normal construction, because we have larger transportations, but with the normal transportations are smaller, but they have a lot more transport, means a lot more CO2 in transportation, and also a lot of more problems for the people that are living around the work areas. So these are partial studies about that. Okay, so we decided to take a look at how we can put together these things that are so different: energy, CO2, the problems to the society, emissions, costs. How can we do that? So we needed a tool that would allow us to mix together many things that are different and give the relative importance that we want to these things. So we decided to use a multi-criteria method that is called MIBES, and this method means that you can deal with all the aspects in one go. I will show you very shortly how. And then you have a view, a global view of what you want to deal with, and you can assign relative weights depending on the needs of the building in that sense. I mean, you don't have to have a general theory for sustainability. You have to analyze in each country and in each special moment what are the consistent weights that you need to give to those. To evaluate sustainability and to try to decide that your solution is good or the best possible. So this is the concept of how you work with this. You're trying to reach a sustainability index, a numerical value, and this goes after 3 levels of individual. What we call the first is the criterion, sub-criterion, and indicators. And how we do that, after each evaluation of these indicators, what we do, of course, we give those indicators a value that goes from 0 to 1. So you relate, for example, costs to a value from 0 to 1, and then you can assign different functions that go from linear, the most simple, increasing or decreasing, or different curve, concave or convex functions that can be more consistent to what you want to evaluate. So you have your indicator, for example, CO2 emissions, and then you are going to make these CO2 emissions into a relative value from 0 to 1. And then you will mix that with cost, with safety, or with the aspect that you want to deal with. So what we did also in this group is to try to apply this and try to give a proposal of how to use this for precast structures. And we have a discussion among the group. We also have seminars, and we ask experts on what would be the indicators that we would use, and what would be the relative weights that we would use for that. So we, of course, we define 9 criteria, 23 indicators. We define from the cradle to the end of the life for circular economy, and we establish the functions. We establish what we should measure, and the abstract of all that is in this table. It's very hard to go in the short time in all this table, but you can see that you have economic, environmental, and social aspect with a weight, and then within economic you divide it into costs, quality, dismantling, or service life. All that are these costs, okay? And then the indicators go a little bit to the right, and then environmental, we have the consumption of materials, emissions, energy, okay? Or social, we have third-party disturbances and pollution, or health and safety. And every unit is different. We define value functions for that, and then at the end, if you give these weights, you end up with a single indicator. So we decided to what we found in our group was these values of economic, environmental, and social aspects, and with variability among our members. With that, you see that in the next slide you will see that these values vary, let's say, considerably, sometimes with some of these LEED, BREEAM, and other systems. You can see there that some of these systems have a big weight on environmental aspects, a very low weight on economic, most of them, and social aspects are also very low. Okay, so we decided to put this available, so you have this information also in the document. And the proposal that we have, we ended up here having this proposal and how to deal with that. And as we don't have a lot of time, I will just show 2 slides of an example. One of the examples that we have in the document is how to deal, what is the most sustainable solution for concrete column for buildings. Let's say a very specific aspect of how to deal with columns. So we decided, this is the example in which economic part is 50% in this case, environmental 33%, and social 17%. And then you decide in different criteria, construction cost, efficiency, and so on, and then you go down to the indicators, and you have to value the indicators in each one of those aspects. Building cost, non-acceptance cost, that means quality, maintenance, habitability, which is very important in columns, or CO2 emission, consumption, and all these aspects. Studying this in detail, all these indicators, then you go down to a single value that is below 1. Okay, and then you can compare, if you evaluate all those aspects, different kinds of columns that are circular in some cases with different compressive strength, with different sizes, and square columns. And then you see at the end, with the parameters that you have decided, because this decision is, let's say, from the engineer, but should be from the final user or from the owner of the building. You go from this definition to the evaluation, and then you see that in this case, maybe because of the parameters that we have used, the columns with the highest concrete strength and the lower cross sections are the best in sustainability, because they are closer to 1. And we can use this tool to evaluate the different kinds of solutions. Okay, and this is the explanation of how one type of column or other type of column can be better or not, depending on the criteria that you have already put in the beginning of the solution. So this ends my presentations. Thank you very much.